In this video, we're going to be taking a look at digital output, or basically how we can drive a voltage from one of our digital pins on the Arduino. So let's kind of flip back to our Arduino view here. And so remember, we have these 14 digital pins out here, and these can either be used as inputs or outputs. Meaning they can either drive a voltage or read in a voltage here. And so digital means, it can either be high or low, on or off. It's these two different binary states that we're dealing with here. And so what we're going to do is we are now going to drive things using the Arduino as opposed to just hardwiring it up to like a battery like we were doing. So I'm going to go ahead and remove this battery from our breadboard here, and we are going to kind of use the Arduino with the breadboard in conjunction to be able to control things like an LED to tell it when to turn on and off. So it's not just dependent on like when there's power on the breadboard or when I've pressed a switch. And so we're going to take a look at how to do that. So let's go ahead and start by wiring up the circuit, and then we'll take a look at the code here. Alright, so what we're going to do is, remember, we always want to avoid using pins 0 and 1. These are for the transmit and receive, and that's used to send information to the computer and send the new programs to the Arduino. So we're going to just start with pin 2 here. We'll use pin 2 for this example. And another thing, kind of using our rule of thumb, is that we don't want to be wiring stuff up while the Arduino is powered, because we could accidentally connect some wire to something else, and it's particularly bad if we're shorting something out, using our Arduino, because, a 9-volt battery is fine. We could, short that out a little bit and it's going to survive, but we want to, kind of be more careful with our Arduino, because it's, a little pricier and a little nicer, and there's a lot more going on there. So I'm going to go ahead and remove the USB, and you see the power present LED is now off. And so now I'm going to take a jumper wire, plug it into pin 2, and then just route that somewhere over to the middle of the board here. Okay? And then I'm going to take a resistor here. And so one important thing is, like, we were working with the 9-volt battery before, but the Arduino is going to operate at 5 volts. So anytime these digital pins are on, it's going to output 5 volts, and when they're off, it's going to output 0 volts. So we're working with a slightly different operating voltage. And so when our voltage is lower, that's going to bring down our current. So we can go ahead and use a lower resistance resistor to protect our LEDs, to kind of still maintain the brightness, because with a lower resistance comes a higher current, and that's going to make it brighter. So oftentimes in different Arduino kits, you get like either 220 or 330 ohm resistors. This one right here is a 220 ohm resistor, and so this is going to be good, for this application. Using 5 volts to power an LED, it'll be nice and bright and not too dim. So I've just wired it in here where one of the terminals of the resistor is plugged into the same row as the jumper, which goes to pin 2, and then the other leg is just plugged into another row. And so now I'm just going to take, I have several different color LEDs. I'm going to take a red one for this. And remember, the longer leg is the positive, so that needs to connect here to the same row as the resistor. Because what's going to happen now is, instead of wiring this to 5 volts, right, we're now wiring it to pin 2, which is going to provide 5 volts. So this is like our positive power rail before. So it's going to go from here, and the current will flow through the resistor and then through the LED. But now we need to return, back to our circuit, right? So before, that was returning to the negative side of the battery. In this case, now what we're going to do is we're going to return it to ground on the Arduino. And there's a few different pins listed as ground here. They're labeled as G and D, and that is always going to be the return path for our circuit here. Alright, so there's a few of them because we need to have a fair number of return paths. And sometimes we might want to route the ground just to the negative rail just so we have a lot of access to it. But for right now, I'm just going to go to this ground pin here, and then I'm going to connect that to the other leg of the LED here. And we should be good to go as far as the hardware is concerned. So what I'm going to do is I'm going to power this on, and we're not going to see anything because I haven't written any code to control this LED yet. So now let's flip over to the code and take a look at what we can do here. Alright, so I'm going to go up to File and New Sketch. so that we can create a new sketch here for this, and I'll close out of that one. And it's going to come up with our same boilerplate setup and loop, right? So previously we were playing around with the serial port and sending messages back and forth. We could continue to do that in this example, but for now, let's just try and get it to control the LED, right? And so if we looked back at the first example program that we took a look at, there was something that was done inside of setup. Remember, it runs once at the very beginning to configure the digital pin, because the digital pins can either be used as an input or an output. And so because it can be used in these two different scenarios that are very different as far as the circuitry is concerned inside of the Arduino, we need to tell the Arduino what we intend to use that pin for, right? So we're going to use a new function that we're talking about called pin mode. We are going to call this function here, and it tells me right here what it expects. It expects a pin number and a mode, right? So here we're going to indicate what pin it's connected to. So I could just say pin 2 here, and then I'm going to tell it the mode, right? And so for right now, we're going to use a special value that's defined by the Arduino that is just output in all uppercase like that. And that's just saying, hey, configure this pin here as an output. And it's a macro that's actually defined behind the scenes for us, one of those all uppercase constant values. Which reminds me, we should probably do that for our pin number here, because we're going to be turning the pin on and off, right? And if I just say, turn off pin 2, turn on pin 2, I might get confused what I was talking about if I had like motors and several other things connected up here. So it's best practices to create a macro for your pin numbers. So the way to create a macro is you're going to go outside of your setup and outside of your loop. So I just kind of added some extra lines up at the top of my program. And I'm going to say pound define. Define. And then what I do is I say the name of whatever it is. So in this case, I'm just going to say LEDR. And it's kind of customary to do it all uppercase to indicate that it is a macro and a constant value. And then I add a space, and then I put whatever value I want this to be kind of aliased as, right? So this is a name that's referring to some specific value. In this case, that value is 2. And another important thing to note here is that I don't need a semicolon on this line. This is actually not really part of the code. This is something called a preprocessor directive. So it's what it does is before it sends the code to the compiler and sends it to the Arduino, what it's going to do is it's going to replace every instance of the word LEDR with the number 2. It's just kind of helpful for us to be able to know what we're talking about. So that's why it doesn't need a semicolon, and it's going up here outside of setup and loop. So now what I can do is instead of 2, I can just say LEDR, right? And if you're programming and want to just kind of check to make sure there aren't any syntax errors as you're going along here, you can hit this check mark, and what it does is it sends it to the compiler to make sure it can compile it. And it's not going to tell you, that your program's going to work 100% the way you expect. It just is checking for like the syntax or the grammar to make sure that you didn't like leave out a semicolon or something like that. The compiler doesn't have a way of knowing your internal thoughts and know that, hey, I want to turn on, a red LED every other second or something like that. It just knows, hey, is this correct grammar? You can think about it as like, your Grammarly spell checker or grammar checker thing. So it can be helpful to do that periodically just to make sure that there's not any like errors that you continue to build upon. So right now we've just done this, and so if I wanted to add a comment to explain what this is doing, I could just say configure the pin as an output. Okay, so I've done that, and we compiled it. It seemed to successfully work, but now that it's configured as an output, let's actually make something happen. Let's turn on this LED, right? So we're going to do that part, and we're going to do this thing here inside of setup. Let's go here inside of loop, and let's actually add code here to turn on the light. And so the way that we drive a digital output here is we say digital write. And again, this is another function. This is a new function that we're talking about. The name is digital write, and in this case, it expects 2 values, 2 input arguments, similar to our pin mode here, where it took the pin number and it took, whether it's an input or an output. In this case, what we're going to do is, again, it still expects the pin number, but it also expects some value that we want it to write to that digital pin, whether it's going to be on or off. And so the pin in this case is just going to be LED R, which is our macro up here defined as 2. And then I'm going to put a comma to separate the two values here. And then I need to tell it whether I want that digital pin to be on or off. And the way that we write that here in the Arduino is we write uppercase high or we write uppercase low. So if we want it on, if we want it to provide 5 volts at that pin, we say high, and then it stays like that. All right. And so now what I'm going to do is I'm going to save it and I'm going to send it to there. And so again, I'm just going to hit save and create like some name for it. I just called it LED. And it's loading back up. All right, so now let's try and send this program over here. And I'm going to switch views here to there. Oh, and we just saw it just turn on there, right? So it's on now forever because loop is running over and over again, and it's turning it high, and it's just always going to stay that way, right? So if we wanted to turn it off, we would need to go back into the code and make that change. So to turn it off, what we could do, so let me add a thing here that just says turn on LED, a little comment to explain that. If I wanted to make it turn off the LED, what I could do is I could copy and paste this. So if I hit Control C on this line, it copies it, and then if I hit Control V on the next line, it'll paste that onto that line there. So I'm going to say digital write LED R, but instead of making it high, I'm going to make it low, and I'll change the comment just indicating that that's what's going on here. It's now turning off the LED. So now I'm going to upload this program. It's going to compile and upload, and let's go to the camera view. And it's just on. Why is it now just on kind of all the time here? If we kind of had a side-by-side comparison, we would see that it's slightly dimmer, but it is still basically on all the time, even though in our code we're saying, okay, turn it high and then turn it low, kind of over and over and over again. Now, if you recall, I said that these lines of code can execute like in a microsecond or in like a couple hundred like nanoseconds range. So what's happening here is loop runs repeatedly. So it's doing the first line, then the second line, and then it's done. So then it goes back to the first line and then the second line. So it's going through all of these steps super, super fast. So it's turning it on for like, a few hundred nanoseconds or something like that, and then turning it off again for a few hundred nanoseconds. So it's doing it so fast that like we can't visibly see what's going on. It just has the effect of kind of making the light look a little dimmer. So if we want to actually see it turn on or off, we're going to need to bring back our delay function, right, that we used in the previous exercise to make it wait before continuing on to the next line of code. So in between here, I'm going to add a delay, and remember it's a function call, so I add the parentheses here. And now inside of there, I'm going to pass some argument or some value that is how many milliseconds I want it to wait. And so here, let's say, I don't know, 1500. Let's make it wait for 1.5 seconds, like this, right? And then it's important that we remember that we would want to delay it again for another, chunk of time, because otherwise what would happen is if I didn't have this line here, it would turn it high, wait like a second and a half, turn it low, and then it immediately goes back here and turns it high. So it would be off for such a small amount of time that we wouldn't even notice it. So it's important to kind of remember to have both of those delays in there if you want it to kind of alternate on and off at the same interval. So it should every minute, or not every minute, every second and a half switch back and forth. So I'm going to upload it, and we'll go over here. So it goes off there for a second as it's uploading everything, but now we see it's just toggling on and off at that interval, which is perfect. That's exactly what we want. So you could kind of continue doing this, right, and wire up even more LEDs. Remember that each LED would need to be driven by a different output because each LED wants a different voltage level. So it's best to kind of drive each new LED from a different pin here, and if you needed to repeat those steps, you could just kind of copy and paste a lot of that, right? So if I wanted to drive, say, like this blue LED from pin 3, what I would do is I would come in here and I would say, okay, let's kind of repeat those steps. Let's say pound define, and then I'll say LED B, and that's going to be connected to pin 3. And then I could copy and paste this line here, and we would just change this to be LED B to say, okay, change that pin now to be an output. And then if we wanted to blink the red one on and off, and then the blue one on and off, let's just copy and paste all this right here and change just a few things here. So instead of it being the red one, it would need to be the blue one here. All right. And so now let's switch back to this view if I can remember my keys. There we go. All right. So I'm going to unplug power, and we'll do this blue one here just real quick. So like that. And I'll use a, oh, that one's bent. Use a slightly different wire here to show how to make it work. So we want to go from pin 3 through the resistor, through the LED, and then as always we want to go back to ground. So now I have an option, right? I could route this wire, which is connected to the negative leg of the LED. I could run it back to another ground pin all the way over here, or since this row right here is already plugged into ground through this wire, I could just connect it right here and we would be in good shape. Because all that matters is that it eventually gets back to ground and completes that circuit, and that is ground, so that's fine. So now we'll plug it back in, and we didn't upload our new version of the program, so let's go do that. So we'll say upload, and we'll switch back. All right, so the red one's on then off, and now the blue one's on then off. Red one on, off. Blue one on, off. Yeah, so you could continue to play around with this, and you could, you know, drive an RGB LED. You could try to mix the various colors of this using, you know, using the different digital pins to turn, you know, the red and blue on at the same time, or the red and green on at the same time, and try to play around with that. There's a lot of different options here.